Thank you for joining us today. This is the introduction to the Common Rail EZ test from Inventa Research and Development. We're going to go ahead and load the application. Once your application loads, you'll notice the user interface, and you'll see this big gray area, which is your scope. We're going to come back to enter all this information. The first thing we're going to do is we're going to select our COM port, and we're going to make our USB connection. So then we get our data coming on the screen. You'll see the large gray panel now becomes an effective oscilloscope. Now these are just random numbers that are random values that are being put on the screen, represented as lines. That's the way an oscilloscope works. It actually uses numbers and converts the data to lines. You'll notice three different colored lines here: a yellow, a green, and a red. The green line is going to be your desired. This is the amount of pressure that you're asking the system to provide. The red line is going to be actual. You can see the numbers changing. This is the red line number changing here. And you'll also notice a maximum setting. It will give you the maximum pressure achieved during any particular test. You see our desired is at 40, and if we change it, now it's 45 here. And you'll see the line just keeps moving up the screen. So we're going to take it back down to 40. Right, and you'll notice this yellow line. This yellow line is your PID output, and it's 0 to 100%. You see the line that's on 100. At 100, it's providing 0 amps to your common rail high pressure pump to control the pressure. Why, you may ask? Because we're below our desired setting. So once our pressure gets above the setting, then we start applying amperage back down towards 0. Can go all the way to 0 to turn it off completely to try to get the pressure, back in range. So we're gonna go above the green line with the red one, and you can see what the yellow line is doing in response to control. Now, how we control how fast this ramps up and the level it's at, this is a calculation, and it's based upon the P, the I, and the D term. And depending on where these settings are and this response level rate here determines how well you maintain the desired pressure during a test. You want to maintain the red line as accurately to the green line as possible. We're going to set this MPa down. Let's see if we can get close to it. Okay, now we see some small reactions because we're hovering at the limit of the PID. You can see once these two lines overlap each other, the red and the green ends up being yellow as well. So that will conclude this part of the demonstration. We're going to go back up here to 40. And now that we familiarized you with the scope, we're going to look at some other settings and things. We're going to go ahead and stop the scope for now and just go ahead and clear it. And we're going to come back to our settings tab. These are called tab controls. And you'll notice here, as I mouse over the tab, this one turns orange. You can customize all these colors. If we want to change the tab hot color, we just pick a color and there it is. So we're going to go back to our previous color. There it is back. This background on the settings page panel, you can change that as well. Would like to make it a little darker, so we'll use this color. Give us a little better definition there. Okay, so that brings us to setting up the customer information. Now when you load this application, the customer name is going to be blank. So you can just add the customer name. And let's say that you're using this interface and you haven't closed it, and you're going to put another customer name in here, so you've got to get rid of the other information that's in here. Same thing applies to this shop name up here. It's the same principle. You'll want to put your own custom shop name here. You can also add phone number, web address, whatever you'd like. But to get rid of this information, there's two possibilities. There may seem there's a third, but you'll encounter problems if you go that way. You can highlight it and just press delete, or you can click at the end of the last letter and you can press delete. Now, it may also seem that you can press the enter key, and it will seem to make the information disappear. And like I said, same thing applies for this, which is your marquee area. The information appears to be gone, but watch this. When I press backspace, there it is again. So if you press enter and you put new information in here, you're going to get an error when you take a screenshot, because the information is going to be garbled. And if I press backspace once it gets to the last and press one more, there is my customer name again. So always make sure you either highlight or just press delete in these text boxes when you do that. So Mr. Doe drives a 2006 Dodge, and it is a 6-injector system. We have 1 through 8 available here. We can test up to 8 injectors. You may want to test in smaller numbers. You may want to, on a Duramax, test 4 at a time, 1 for each bank when you do your flow testing. And these numbers represent total combined volume for the amount of injectors selected here. So when we go to do our injector testing, it's going to give us a pass or fail volume rating based upon the number of injectors selected here. That brings us to our rail pressure sensor selection, and we're going to discuss this just a little bit. Why do we not have it auto select this? Well, for some performance applications and racing applications, very good to use this tool for high performance applications. Guys are putting higher resolution sensors in here, and typically what we did, we would do a higher resolution sensor, and then we would set the rail pressure relief valve to open at a lower range. So in data logging, you could pick up pressure spikes and you could see exactly what's going on. So if you got a system, if you got a relief valve set at 2000 bar or 200 MPa, and your sensor only goes to 180, and you're going down the track wide open, well, it's just going to look like it's pegged out all the time. You're not going to know exactly what you're doing. I like to know exactly what's going on. So like I said, for a lot of applications, we would do that. So this gives you the ability, if it's a stock truck and it's got, this particular sensor in, go ahead and select it. Otherwise, if it's custom, you can alter it based upon that. And we've got the information with the sensor part numbers and the application specifics in our instruction documentation. So you don't have to guess. If you get the part number off of the sensor, we can determine which one it is in our documentation. So that brings us again to our COM ports. Now, as long as you have your USB cable connected at the time you load this application, it's going to automatically populate this drop-down menu with all the available ports that are occupied. But in the event that you've started the application, then you've made your connection, you would want to press the refresh button, which surrounds this drop-down menu, and then make your selection from it. And if you don't know which port your USB controller is connected to, you can go to your device manager and connect it, and it should populate in your device manager and show you which one it is, and that's going to be the port you select. If you select the wrong one, you're just not going to get a connection. You're going to get a timeout with an error, and you may have to reload the application again. These are settings for some of the tests, and we've already showed you how we can change these colors and things. We're going to come back to these, but for now, we're going to go ahead and put a custom name in here. We're going to highlight and press backspace to delete. And we're going to put our information in here. It's an Inventa CREZ test, CR for Common Rail. And we're going to use our website, which is Inventa rnd.com. Make sure I spelled everything right. And we're going to come back to the settings tab. Now you can customize this. You can change the font style and the size. Typically you can go up to about a 24. I normally go about a 22. For some of these fonts, they're going to appear a little bit larger than other fonts. And we're going to choose this one, extra bold. This will load your system fonts from your computer. Whatever fonts are installed will be displayed here. And it's only going to allow a true type font, TTF font, to be used. And you may have other type fonts in here. And apparently they have bad metadata. So if you select a font that is not a true type font, when you press OK, it's going to give you an error. It's not going to allow you to be able to use that font. So we've made this selection, and yeah, seems to be okay. And if you want to change the color of the font itself, I like this orange color. Has the greatest visibility over the greatest distance. And then we're going to do a dark color for the back color. And once you make changes, these will be saved. Whatever you've selected as far as colors and your enhancements and the line type and your flow meter calibration, scope update rate, these settings here are not saved. These will be user defined upon each use of the program. These settings for your PID will be saved until you change them again by simply pressing this save button with the floppy on it. So let's discuss why we have all this information in here and how important it is. Well, once you load the customer information, it's going to display on the screen here as well with the sensor, and there will be no evidence against what you're doing here. Once you take a screenshot, it's going to show exactly the selections that you've put in here. So we're going to start the screen plotting data again. And we're going to go ahead, since we've got all this information in here, and we're going to go ahead and take a screenshot. And we're going to stop the screen. And we're going to come back and look at the screenshot. Now this is it, the one we just took. And we can go full screen with it. And we see our shop name. We see the customer name, his vehicle, all the selections. We see all the testing results will be displayed here. This thing has the capability at the end of some of the tests, it'll go ahead and take a screenshot for you. And we'll talk about those later on. But something else to notice here too, this is the time of testing, Tuesday, September 5th, 2017, 8:51:16. So we'll go ahead and close this. So let's talk about screenshots for a minute. In this day and age, we'll go ahead and maximize this screen and fill in our screen area with our background. In this day and age, credibility is a wonderful thing. Some people are out to get you, including customers. Some of them want to sue you, take you to court. They're going to say, oh, you did this or you did that. Well, these screenshots can do a couple of things. One, they can protect you. So you can go ahead and take screenshots of all your tests, put them in a folder. And what it does, it generates a folder with this customer name. You see here, John Doe, Inventa, in local disk C. It's going to go ahead, and you don't even have to do this. It's automatically going to generate a folder. And if this customer's name is already in here, if you haven't made any modifications to this file, if this customer's name is already in here, and a thing to consider too, if you've got two customers by the same name, you're going to want to put a middle name or more information in the customer name to have the ability to discern between these two customers. But let's say this customer comes back 6 months later and you do more testing, it's automatically going to put the screenshots, it's going to automatically associate the screenshot with the customer name as long as it's spelled the same, and it's not going to generate a new file. It's just going to stick it in C in what already exists. So at the time you load this program, you load the first screenshot, it's going to generate a folder in C named Inventa, and it's going to put this customer name in here. And each new customer name, it's going to generate a folder with the screenshots in it for each new customer, and it's going to put a timestamp and a date. And you can look back and you can say, oh, okay, this was the results, from the time before. And these are the results this time, and it's getting worse. So it's time to do something about it. Or let's say, your customer is really busy. He's a businessman, and he's in meetings all day long. He's really hard to get a hold of. But he says, if you send me a text message, he said, I'll respond back to you. So you don't have time to really explain things. So you send him a screenshot, and we've run an injector test. Let's go ahead and see if we can make one come up here that fails. Oh, okay, we failed. So we're over limit on our injector return. So we're going to send him a screenshot. He said, okay, I'm going to authorize you to do X amount of dollars worth of testing. And if you need to go deeper, you need to contact me. So you can go ahead and take this screenshot and send it to him. It's a regular JPEG. Send it to him in a text message. Say, look, we're at 100%. You got a problem. We're going to have to go deeper. And he'll respond back, okay, I authorize you to do this or do that. Another thing to consider too, let's say that your customer's not pleased with you. He thinks that you've ripped him off and he's going to take you to court. Well, this is good evidence, to back you up if you've done everything as you should be doing it in an honest business. And he's really just out, looking for something for nothing. He did have problems, and you did try to fix it, but he didn't want to spend any money. So now he's going to try to give you a bad reputation. Well, here's your evidence to back you up if you've done everything the way you should do it. You, like I said again, you've got the time, you've got the date, you've got the test results, you've got all this information. You can keep it in the folder, and you can use it in a court of law. I mean, it's actual evidence. So that's another benefit. Or if you've done something wrong, the customer could potentially use it against you. Wouldn't be good for you in that case, but it would be good for him. But it holds us to accountability, just like customer feedback holds us to greater accountability. And we're all accountable in the end. I promise you that. So enough about screenshots. We're going to start the screen recording again. And we're going to talk about some of these other settings. Like this PID, you can turn it on or off. That is the yellow line that's going to show on the screen here. You can turn that on or off. You can have the scope graph to display. Now this isn't sample hertz. This is display hertz. It's going to be updating at 40 hertz here. You see the information is coming on a lot faster. And it's not even really necessary for most of the testing that we're doing. If you're really trying to catch, some problem, with the greatest resolution, you can set it to 40 hertz to try to do that. So we're going to show you some more things about this scope. If we want to look at a value now, you can see that we've got this thing set to 10, which represents at 10 hertz. It represents 10 seconds. And if you've got it set at 20 hertz, it's going to be 5 seconds. If you've got it set at 40 hertz, it's going to be 2.5 seconds. So with it set at 10, let's say we want to look at one area. We're going to stop our scope and we're going to say, okay, I want to see the transition here. So you can drag your mouse and highlight that area, and you can zoom in and you can see, approximately where it was. It's not going to really show you the pressure zoomed here. You can get rid of the zoom on pressure and just highlight this one area. But if you want to really have a time tag and a pressure tag of what's going on, we'll start the scope back. If you put this to 0, it's going to be a free run. So what's going to happen if we're set to 10 roughly, you'll see things start accumulating on the screen, and then once it gets to 10 here, whatever it's set at, then it's going to start scrolling across the screen, and new data is going to be added as old data goes away. So if we set this thing to 10, it's going to continuously plot data until you stop it. So if you want to say, I want to run a test for 2 minutes and see what happens. 60 is actually 6.0, 6 seconds. 12 would be 12 seconds. So if you want to see what's going to be going on, 600 is going to be a minute. So 1200 is going to be 2 minutes. So you're going to get a lot of data on here within that time. And if you want to look, if you want to stop and say, all right, I want to know what was going on right there. How long did it take to get there, and what was the actual pressure? I see it's between 140 and 160, but now you can do it. You can say, all right, 14.7 seconds. The MPa was at 156.34, and you can keep clicking, and it'll add a new one at whatever point. If you want to get rid of this, you click off. Now let's expand in. Let's say I want to highlight this area and check what's going on here. Well, you can do the same thing at a zoom level, or you click off, and then you go to the end of each one of these track bars, and you click off on those. So very powerful. A scope is the greatest information that you can have in Common Rail, or any type of testing as far as I'm concerned, to do with mechanical things, with sensors, and you're looking for pressures and pressure over time. A scope's the only way to do it. So we're going to go ahead and clear the scope again and turn it back on. Now each time you make a setting change here, it's going to clear the screen. It's going to continue to clear it until you stop at a setting, and then it's going to start populating the data on the screen. So there's no save to this part of things, just for our settings. You click here and see the information folder that contains your instructions and settings and testing information, things of that nature. So we're going to go ahead. We're still stuck in the injector return test here. We'll go ahead and clear out of that. It's going to give you an audible notice telling you that you've stopped the test. Going to give you an audible notice when you start a test, same one. So we're going to look at some of the other tests. We're going to look at a pressure build rate test and see if we can start one of those. Now, if you look over here, build MPa settings, we're going to start at 40. We're going to start a timer once we get above 40. 40 or above, and we're going to stop a timer once we get to 160. So what would be a practical use for this? Well, if we set it down to like 5, I'm going to set it back to 30, but if we set it down to 5, once you start cranking the engine and it achieves that pressure, it's going to start plotting the information on the screen. So let's see if we can. It's got to be between those levels to start plotting the information. All right. I made it to 174 MPa in 0.005 of a second, and it should have taken a screenshot. It did. So that's one of your automatic generated screenshots. It'll say, and if there was information plotted on the screen, it would show it here. It's going to show us how long it took to build this pressure. So one of the first tests that you're probably going to want to do is you're going to see how long, if the customer's complaining, well, it's my vehicle, just doesn't accelerate good, doesn't seem to have good power, you're going to want to do one of these pressure build tests. And we can set this level between, I think you should be able to go all the way down to 5 and set it up to typically about 160 or whatever. So what you're going to want to do on this side of things is start cranking the engine. Once it starts, then you can accelerate. And when you mash the throttle, you can let it idle. You can start it up and let it idle. Let's see if it'll actually put any information on the screen here. Give us something a little more to look at here. I got to reselect it. Build rate, start. And we're above it, so we're getting time here. And we got up to 176. We run it for 12 seconds. So it's going to start here again, but it's going to still give us the time. Press stop and it's going to clear it off. So we would, and you'll see when we're actually running these tests, and in that video you'll see the actual recording on the screen. But we can do a similar thing with the leak rate. We would use that to isolate individual injector problems. We could test a multitude of injectors together, or isolate them down to one. So I believe this has covered most of the features. These green boxes we can check, those are dependent a lot on processing power of the computer, so you can change these settings. We'll go deeper into that later. Graphing color, scope update rate. This is also another thing to, you can see how it's kind of moving along notchy right now in segments. How the display is added to the screen, or how the information is displayed and added to the screen. We can take this back down one. This also depends a lot on individual processing power. If you've got an older computer, you can raise this scope update rate so it's not trying to deal with so much graphic information at one time. So you can really reduce the requirements and processing power required to operate this program down to where you can use it on a 1 gigahertz processor. We've done that. Or if you've got a fast processor like the one on this computer, you can use all the higher settings. So this concludes the introduction to the Common Rail EZ test from Inventa Research and Development. We thank you for watching.